Hello, welcome to Ekidel. My name is Justice Nwaka and I am your instructor. Today, I will be showing you about end condition. Now, when I mean by end condition, I simply means fixed end and what hinge end. Now, most engineers don't used to apply this on their structure and they don't know the impact this affects their structure. So, on today's video, I will be showing you the difference between hinge end and fixed end of your structure. Now, this video will not be that interesting because I'm not going to use a very massive building. I will just use different models of beam and four models that have the same depth, the same width, and the same loading and the same size of their supports and everything. But I will urge you to stay to the end of this video because by the end of this video you will see the difference between when you apply a hinge end on your structure and when you do apply a fixed end on your structure, and you also see how the hinge end will also affect your your member or your support, which is the column, and also how the fixed end will also affect either your beam or the support, which is the column. Now, if you look at this model here, I have made four different models, and I applied different end conditions, which is the hinge end and the fixed end. And as you can see, after I did my building analysis and all that, you can see that most of the columns are failing. Now, each of these models have everything in common. They have the same loading, they have the same size, they have everything in common, but as you can see right now, the first one here, everything is passing, while the second one here, some things are failing. That's because some moment is being induced into the support, and this affects your structure if you don't apply the hinge end or the fixed end. Now, most engineers just apply only one and all that, which is the fixed, and don't even consider applying hinge. And I say every time that they end up wasting their clients' money, because when you don't apply hinge end on a structure, you will see that you will have bigger section size, or you will be having much number of reinforcement or larger sizes, and these things is not really good because it affects the cost of that construction, either a building or a structure. So with this video today, you will be able to clear all those doubts and also all other stuff. Okay, so right now we are going to walk back now to the to this plan view now, and on this plan view we are going to make make three or four models, okay, that has similar length. As you can see, here is 7.5 meters length, here also 7.5 meters length, but some things here are failing, and also this one at 7.5. This is for a continuous beam, and this is for also a continuous beam. And the only difference is that on this first one here, this first one has different end condition, which is the hinge, and here has the next which is the fixed end condition. Now, I will now walk you through from the beginning so that you'll be able to see the impact this affects your structure, so that next time when you are performing your design on any engineering software, you will be able to apply each and every of these end condition, either hinge or fixed or pin. They still mean the same thing. So right now, let's now begin to what we have for today. Okay, that's fine. Okay, so right now, as you can see, I have created different grids and also at different parts, and also, as you can see, each of the grids does not have any connection to each other. As you can see, this is just for grid line 1, 2, and grid line A, and this other one is grid line 3, 4, and C, and so on and also so forth. So right now, this is now for just a one span beam, and this is also for a one span beam. On this first one, we are going to apply a hinge end, and on this second one here, we are going to apply a fixed end. And on this continuous beam, which is a two span beam, on this first continuous beam here, we are going to apply a hinge end. Why this one here we just leave it at as fixed end, and you will see the impact it will do affect on each of the member. Okay, so right now let's now insert our columns on this. We are going to use the same column sizes for all of them, and also the same beam size for all of them. Okay, so right now let's now begin. So right now on the column, I'll click on the column right now, and then put in my column sizes 225 by 225. I say again, it will be very, very boring video, but if you stay to the end, you will see the you will gonna see what you will learn by the end of this video, and which will also change how you also model or design your structure. Okay, that's fine. So with this now, the next thing now do right now is now do what, insert our column here. So I'll just click here right now, highlight, and then insert. That's fine. As you can see right now, we now have our first column here, and also come again right now, highlight here again, another column will be there, and again come again now, highlight here again, and that is fine. Okay, we now have our two span here, and again come here again, highlight again. Okay, that's fine. So now you can now see that we used the same size of column for all these 4 samples that we have here, right? That's fine. Let's now go for beams now. Okay, now if you look again now on this sample, you can see that they are all what, 7.5, and also here 7.5, and also here 7.5, 7.5. So we did this so that you can be able to see how it will affect, that end condition will affect the structure. Okay, that's fine. So on this again, now let's now move on to what beam. Okay, so on this beam too, we will still use the same sizes. Okay, so 225, and then let's try to do what, 450, although 450 will fail because of the length of the span, 7.5. but let us try this first at the beam depth and all that. Then during the design, if it fails, we cannot choose to do what, increase. Okay, so right now I will then come up here now, do again, highlight again here, and then the beam will be what, there. That's fine. And again I'll come again now, highlight here again right now, like this now, and again the beam also will be there also. That's fine. Okay, highlight here, and the beam will be there, and again here also highlight for this 2 span beam now, and our beam will be there. That's fine. And again come here again, highlight again here, and the beam will also be what, here. That's fine. So with this now, we have now done what, we have now done a model of what, of this. Okay, so you can see now. So let's now begin to do what, apply the end conditions on it. Okay, so on this now, on this first one here, we are going to apply what, we are going to apply a hinge end. Okay, and this one here, we'll just leave it as what, fixed, because at default this software takes everything as what, fixed. So it is now you to assign a hinge end and all that. Okay, so right now if you want to assign, let's now assign here as what, as a hinge end, because here is free, and sorry, because here is going to be a hinge end, and also here a hinge end, knowing that the since this is an end of a beam, all right, moment at end is what, tends to what, 0. Okay, now if you want to watch more of this, I did the video yesterday. You can now watch that that video I did just yesterday, and you'll be able to see how I explained how to hinge. Okay, and all that. Okay, so right now let's now apply what, the hinge here, which is now gone what, I'll come here right now, end condition, and say or both end hinge. Okay, and then okay, so you can now see that there is now what, a 0 sign here, which simply what, that the m here is what, 0, knowing that since this is not a hinge end, we have not done what, applied hinge here. So therefore that m here, all right, moment here is not equals to what, 0. Okay, also the same thing here applied to this other. Now for this other one here, we will leave it as what, as fixed. Okay, as it is, without applying anything, which most of you guys do when you're doing your design on this software. Okay, then on this other one now, which is not a 2 span beam, we will also apply what, hinge end just at the end here. Right click now, and then apply at what, at I. Okay, because here is I, so right click now, and then apply at what, at I. Okay, that's fine, apply at I, and again come to this other end here, apply again here as what, at J. Okay, that's fine. So right now this now becomes what, a hinge end, and here also becomes a hinge end. Why the center here becomes what, a fixed end, because this place is going to have what, it's going to have a positive what, moment at this place. Okay, so that's why it is a fixed end. Okay, that's fine. Then this other one now, which is this sample of this other one too, we are going to leave it as what, as fixed, without applying anything. Okay, so right now we now have what, we now have 2 samples. Okay, the first one here is for just a 1 span beam that has what, that has hinge end and what, hinge end here. Now the same beam again on this other side, now we did not apply what, hinge end, so here is just what, fixed. Okay, now on this other one now, which have 2 span beam, we applied hinge here and also hinge here. Now again for this other one now, we didn't apply what, hinge. So you now begin to see how this thing will affect. Okay, so right now back to our 3D view. Right now that we are done what, modeling, let's now go and do what, perform loading. Okay, now go and load the beams. Okay, so right now I will then come down here, click on this beam now. Right now they will have the same loading for all of them. Right click now and then do what? Edit load. Okay, that's fine. Now on this place now, the next thing we do right now, we are going to apply two loads. The first one here will be what? Will be will I be the wall load. So I'll click on the wall load now, and then put in, okay, I've already put in the value here, 3.47. Okay, that's fine. And then let's assume that the height is what, 3 meters, and that's fine. And the block wall weight is this, the block wall thickness is this, that's fine. I'll then come here and do what? Apply this here. Okay, so since I've applied the wall load now, let me still increase this load here, all right, which is this arrow2 and what arrow2 here, which is the what which is now the beam what reaction. Okay, that's fine. So right now let us also go and apply what? Another load again, additional load, which is the what this is that load here, UDL here, and then come here. Let me just apply that. I want to apply a load of what? 9.81. Okay, again additional. I will then come again right now, apply it again. Okay, just to see how these beams will behave based on the same loading. Okay, so I'll come now and do what? Click on what? Okay, that's fine. So with this now, you can see our load now is there. I will then copy this same load now and now paste it on all other of our models. Okay, I'll copy now and then paste it. So they have the same loading, they have the same column sizes, they have the same span, everything is the same and the same thing. So but the only thing that is different now is the end condition. Okay, so I'll come now again, click here and come now, right click here and then paste what? Paste load. Okay, so right now you can see that all of them now have what? The same loading, the same column sizes, they are there, the same beam depth, they are there, and everything. So now that we are done with the loading now, let's now go and perform the what? The building what? Analysis first and then design. You will now begin to see the effect of what this hinge end here, which you have here, on this first model here, and this other one here that we did not hinge, that is what that is as fixed. You will see how it will behave, and also on this other one, and then you will be able to see the one that is cheaper. Okay, because I always tell you guys that if you don't hinge, you will waste your client's money. Okay, so let's now have a proof of what of the things which I've been saying here on Ekidel. Okay, that's fine. Let's now go on now and then go to, first of all, save here. Okay, so on the saving now, we will then go and do what? Choose our what? Material, concrete grade and all that. So right now let's now go and do what now? Choose our concrete grade now. Okay, analysis here, sorry, just close here, analysis here, then come here and choose our what property here. I can choose what? C20 as my concrete grade. That's fine. Okay, that's okay, C20. So you can also try this now on your own side. Okay, try it on your side. You can see the sizes of the listener I use and the spacing there. Then for here now, let me just choose 410 as it is, as my bar strength. Okay, and then for the rebars now, let me see, for there's no slab here, so only column will have column. I can choose column to be what? 16, 20, 25. That's fine. Then for beam, I can add 12. Okay, and then although 12 is not good for beams. Okay, but just to show you that, let me say, if you want to reduce cost, then you'll be able to see that. Okay, so I'll add 12 for beam, and then 16 to 25. That's fine. And again, I'll just that's all we have. Then links, I'll just add 8 and 10. Okay, and not 12. Okay, and then I'll come down and do what? Say okay here, and then come here and do what? Say okay again, and then okay again. That's fine. So on this now, we have also defined our loadings here before, as you can see that. Then just say okay here. So with this now, we'll now enter into what? This tab here, analysis tab here, and then first of all, let's do just a check of our what model. Okay, and see if everything is nice. Okay, that's fine. You can see right now that there is no error on our model. Let's now move on to what? The building design. Okay, analysis and design, and then on this place now, let us hold on for that to complete and all that. Then come now, click on this to design and everything, and then say what? Analysis here. That's fine. So let's now hold on for that to what? Finish in less than 1 minute, or let me say 2 minutes. It will be able to finish up the whole bit analysis and what design. So you'll be able to see the difference now of how to apply what, like when you apply hinge and what, and then fix. I'll just come and they will say yes. Okay, so you have to see how what will happen, all right, when you apply what hinge and when you just leave it as it is at what's fixed. Okay, that's fine. So this is now okay, and then come down and say what? Okay here, and then come back now, and then come here and do what? Close here. Okay, that's fine. So right now it is not time for us to now go and do what? Go and do our what? Check-ins. Okay, now let's now move on to what? The let's do the what? And review come here and do what? Status of design. Okay, so with this now you can see that first on this first one here that has what? That has hinge. Okay, here is the hinge one. Let me just go back again and do something here. Let me just try to bring out a view again so that you can be able to see the two differences. Okay, let me just do it again right now. So you will see, so on this first one now, yeah, correct. Let me just move this like this, keep this here, that's fine. So on this first one, let me just come here, we can move again like this now. Okay, that's fine. So on this first one now, you can see the first beam here, we applied what? Hinge here and then hinge here. Okay, that's fine. So let's now see how the first one behaves after our design. So you can see it here now that the first one here, all the columns are okay, they are passing, they are stable to like do what? Carry the load, but the beam isn't failing. Yes, that's fine. That's because the length of the span is what? 7.5, and we are using what? Beam depth of what? 450, which is not nice. Okay, let's now go and do the review of the what? Of the one that is fixed. Okay, now on the fixed one here, you can now see that all the columns are failing. Can you see that? The columns is failing, the beam is failing, the column is failing. But this other one right now, the columns was what? Okay. That's because what? There is no moment, all right, transferring from the beam into the column, because we have already assigned what? Assigned that the m here moment here at end is what? 0. Okay, so all the effect is just on the beam and no one is going to the column. Okay, now let's now begin to now see the effect first. By let us first and begin to change check why the beam is failing before we now come and check for the columns. Okay, that's fine. So for the beams now, let's now begin to work on the first one first. I will still show you these two later, but let us work on these two first. So on the beam now, I will then come here, click here, right click here, and then do what? Say session design here, that's fine, and then just say okay first. Okay, now let's now see why it's failing and just say either no or yes. Let me just say yes. You can see that it is failing what? Based on what? L over D. That means that the depth of the 450 is too small for the span of what? 7.5. That is nice, that's okay. So right now we're gonna come and do what? Come here and then increase our depth to what? 600, which is nice to carry to for that kind of length of span. Okay, that's fine. So come down and say what? Rebar here, and then you see that it is now okay. What? That's okay. So now let's now begin to do what? Reduce our what? Material, our what? Our bar diameter and the bar size to get at least the actual size that will be able to do what? Pass it. Okay, that will be able to okay with it, because my god, this software most times perform what? Over design. So let's now begin to now reduce what? The sizes. Okay, so with this now, knowing that this here is for the one that has what? That has a pin end, which is a hinge. Okay, a hinge end. So with this now, then come and reduce this now to 2y16. Okay, that's fine. So 2y16 now is able to carry the this top bar here. Okay, that's fine. Now for this other one that says what? Button here, let's now try to do what? Also reduce here, reduce, yeah, then reduce here. Let me see. Okay, no, it is failing here. Can you see that? So at 4y20 it is okay. So with this now, you can see that at the top here 2y16 and bottom is what? 4y20. Okay, and we have a column of what? 225 by what? 225 by the supports, and it is all okay. Okay, that's fine. This other one here, I've already explained a lot here, that once this place here is showing red, these two places that have what? Less than or equal to sign, as long as the value is what? Is more than 20, it is okay. You can watch other of my videos and then learn what I said about here. Okay, but for now, this being right now is now what? Is okay now. We can now come and do what? Say yeah, okay here, that's fine. You can see that it is now what? Green. Okay, now knowing that the bars that we have here at the top was what? 2y16 and one at the bottom is what? 4y20. Okay, that's fine. Let's now go and check out for this other one too that has the same thing, but here now is now fixed. Okay, here now is a fixed end. Okay, why here was what? Was a pin end. Okay, so right now on this other one right now, let's now go and do what? Right here, click on this, right click here, and so you can try this on your own, because try it and then see. All right, so that next time you will be able to value that hinging. Okay, so right now I'll just say yes again, that's fine, and again it is failing based on what? The depth. I'll still can use what? The same depth we use for the what? For the pin. Okay, I'll come now and do the same thing here, 600 here. Okay, 600 here, and then come here, click on this place now. Okay, it did not change. Let me come again now. Put again here 600 here, and then click anywhere first, and then come here now, rebars. Okay, so it has changed again. So right now again everything looks okay. Let's now can do also reduce the bar to get the what minimum. Okay, so down now and then down again to 16. That's fine. The same thing we got on the other one, but you can see that this area of steel here is very small, 7 point something. Can you see that? 7.38, which is the area of steel. Why the other one was what higher? Okay, that's because this is a fixed end, and what it is kind of what moment here. Don't worry, I will show you about the BM diagram and you will see it. Okay, that's fine. So right now I will then come back here and also try to reduce, but we can leave this as it is because one, it is not failing, but just that this bar here, area of steel, is very small. If it is for a real life, I would have advised you guys increase to what 3 to have at least enough area of steel at the top. Okay, so right now you can see that when we now reduced this button, just watch, to first it was what 25 before, we now reduce to what 4y what 20. It is failing. Can you see that? It is fading, but the other one was passing what 4y20. Okay, and this is for a fixed end. The other one is what a pin end. So now you can see that 4y20 is not what sufficient, and that means that it is not stable to carry the load on this beam. Know that they all have the same loading, okay, that we did, okay, and they have the same what spans. Okay, that's fine. So with this now, I will then come and then increase a bit, okay, by what 25, and then now begin to now do what reduce the number. Okay, so you can see that even at 2 it is still failing. So right now you can see that 3 will be able to pass. So you can see that now let us assume that we want to still use what y20, so that we can be able to equate it to the number that we had on that pin hinge end. Okay, so right now let's use y20 and see how many y20 will be able to carry this beam. Okay, so right now at 4 it is still failing here. So let's now go and do what, add a support bar, add again here, add, and then let's just do what lap. Okay, and again here lap again. Okay, lap here again, lap, that's fine. And again now let's now check now, let us now increase, add. Okay, so you can see that, let me see again right now. Okay, let me now try to do something by reducing here to what 3y20, and then let's now increase to, let's just see 3y16. Okay, that's fine. So you can see that right now they need what much number of what bar at the bottom. Basically, if we are going to do it at y20, what the like number of what that is now needed here, let's assume it is what let's just check now. Let's check, reduce. Okay, so you can see that at 4 it is failing. So at 5, so basically, sorry, it's 6. Basically this thing needs what 6y20. all right, 6y20 is needed, all right, against the one that was with what pin. Okay, and then at the top here, okay, let me assume that we are going to use this smaller area, but which is not what good to use, because this area is already too small, and the spacing for the link here, just watch now, is what 200 here, 200 here, and here 275. Okay, so you can now see the value of what we have here on this one that is what fixed. Okay, now I'll now say what okay, so you can now see that the same depth that we have here, 600 here, the column same thing, but here is failing currently. Then here now same depth again, same thing for the beams. If I now check for this beam now, first let us and first finish up what for the beams first. Okay, so you can see that this other one that is what hinge here, this hinge, you can see that we have what a massive extra area of what reinforcement of 100. The other one was showing what 7.5. okay, that is very, very bad. Okay, so you can see that the other one was showing what 7.5, which is the fixed, and the pin here, which is the pin here, is what we are having what 100 and something as the area of steel, and we have what 2y16 at the top and 4y20 at the bottom, whereas the other one that was what fixed, all right, we got what approximately 3y16 at the top, because that 7 point something that they're seeing there as that area of steel is not okay to be used. Okay, and then we now got at the bottom, we had what 6y20, but you can see that on this place right now 4y20 was okay, so you can see that if you don't hinge, if you don't hinge, you can see that you will be having more what moment. Now let's now begin to do what check out for the what diagram of the what moment. Okay, now let's now go there now, and now before we go there, let's go and increase this other one first for the top that was what 2y16, that was having smaller what extra area for reinforcement, which is not nice. Here it was 7 point something, so come here and do what increase to what 3. Okay, that's fine. So you can see that from the at the pin side, at the pin, all right, we had here what 2, as you can see it here, we have to be what 2, and then for the bottom reinforcement we have to be what 4y16 for the pin. But here that is the fixed here, we're having what 6y20, 3 at the first layer, 2 at the second layer, making it what 6y20, which is more expensive to construct compared to the other one. Okay, and they all have the same span, the same loading. Okay, then for the links, the links are okay, because for the pin we also have what 200 200. Okay, so they have the same links under that spacing. Now let's now look at for the what for the moment. Okay, now let's now go to the this moment now. Okay, before now enter for the columns, why here is failing. Okay, now let's now go here now. Moment of this now, the diagram of this, you will see that why this one is not having much bar is because we applied what hinge end. Okay, we applied hinge end on the end of the beam. Now on the diagram now, you will be able to see it now. You can now see that since it is what since we applied what hinge end here, moment now is equal to what 0. That's why it is not passing this line, this black line. This black line simply means what line of what neutral axis. Okay, so right now you can see that since we applied what to be what hinge, that means that this moment that is passing here is not going to cross this line here because of what we apply what hinge. So it's going to have only the bottom reinforcement. That 2y16 that you saw at the top is just because it applied what the code says. Code says that when a beam does not require top bars, but just for the stability to be able to hold the like the links at the top, provide what 2y16 as the word minimum. Okay, that's what the code says. Okay, so with this now we can then with this now you have seen that okay, we are still on the review. Okay, but now you have now seen how the BM diagram of this one is. Okay, that's fine. I'll now do what exit and then close. Okay, I'll then come again now for this other one now to see the BM diagram of this other one now. I'll then come now and then do what section design here, and then go for the BM diagram here. You will see that since it is fixed, okay, you can see now can you see it here? The other one now, which is the other BM diagram, stopped directly under this black line. It didn't cross, but since here was a fixed, okay, you can now see that it now crossed and now induced what a top moment. Can you see that now? It has induced a top moment, and because of this here, that's why you are having more reinforcement at the top, which gives you what 3y16. And that's not all. You will also see the impact of what this top moment here will do what act on the column. As you can see, the column of that fixed end is what failing. All right, the supporting column is what failing. You also see the impact which it will also affect. Okay, and all that. Okay, so right now you can now see the two top and this here moments here are having what top moments here, and also on this side too. That's because they are what fixed. Okay, that fixed end used to induce what top moments. All right, on that, and also induce moment into the supporting members, either columns or walls. Okay, but now in this case it is we use what column as a support of the beams. Okay, so now you'll be able to see how the beam will also transfer what moment into the column. That's why the columns are what failing. Now let me now show you now. That is the reason why these columns here are failing, because here is a fixed end, and that top this thing that was here, right, moment is now being induced into the column. So because of that, the column needs to be bigger. All right, needs some size to be bigger to be able to do what, carry that force, all right, moment from the beam plus its own load and everything. That's why it is failing. But in this other case now, in this other case here, since we apply that to be what 0, which is a hinge end, it means that this beam on no account will it transfer what moment into the column. That's why you can see that the columns are what passing. Now let's now begin to see the bars on the column. Now first, before I enter into the column, you have seen that for this beam that was hinge, all right, we are having what 2y16 at the top and 4y20 at the bottom, which is what cheaper compared to the one that was not hinged, that is fixed. on this fixed one here, we are having what 3y16 at the top and 6y20 at the bottom. So in this case now, which is cheaper for the client to like afford? Based on the beam now, you can see that the one that is hinge is more cheaper compared to the one that is fixed. That's because we are having what lesser number of what reinforcements, okay, and they all have the same loading, the same span, all right, the same span 7.5 and 7.5, the same depth of beam 600 and 225, and also the same thing here happens here, okay. And you saw how they have what the same loading because we use the same load to paste in all of them, okay. And I can see that they all also have the same what column sizes at this end and also at this end here, okay, which is on this hinge end, all the columns are passing, but the same column size here, you can see that it is failing. That's because it is a fixed end. There are some moments from the beam that is now induced into the column, which is now affecting the column because the column right now is taking what moment from the beam and it tends to what to get bigger. That's why it is failing, okay. So right now let's now begin to first of all look at for the bars now of the column, knowing that for this hinge end the column of this column size is okay to do what pass that, okay, that's fine. So with this now, we then go and then check out for the size now of the what of the bar, okay. Now for the bar now, you can see that on this place now, you can now see that it is what showing what 4y16, okay, that's fine. And also the same thing happening here too, this other side too happening here. Right click here, properties here, okay. Now again here 4y16 here, as you can see again here 4y16, can you see that? That's fine. So again I'll then go okay now and then come here. Now you can see that here is failing. I can see that it is showing red. Now let's now go and see why it is failing, okay. Right, and click on it now, right click now and then do what design here, and then now check at this here. You can now see that there is a warning that is showing here. They say what section size is what insufficient. That's because the column on its own is what is taking moments from the beam, okay. And when we check that top moment, that was what around 73 point something, okay, kilonewton meter that was coming from the beam into the column. That's because we did what apply that one to be what as a fixed end and not at a what hinge end, okay, that's fine. So with this now, let's now since we are focusing on what making the like the whole building to be what stable, all right, the stability, okay, before we now check at the cost, all right, the cost, okay. So we'll now make this column first to like do what pass, okay. So with this now, I will then do what try 300 and then see update size and see, and let's see. You can see that at 300 we are having what 4y what 25 against 4y16 that we got in what when it was hinge, okay. Now here is fixed, we're having what 4y25 at what column of what 300 width length, okay, length, that's fine. If we try to use 250, let's just try again 250, let's try and see, let's see. It is not passing. Can you see that? So basically right now you can see that the minimum size of column that can pass for the for this support, which is the column here that is for the fixed end, is what 225 by what 300, okay. Now update now and then design, and the bar size also is also what 4y what 20 against 4y16 that we are getting, okay. I'll then come here and do what say okay here, and then come here and then say okay here, correct, okay here, that's fine. So you can see now that the column size here has increased, which has increased more cost on the clients, knowing that for this other one that was fixed, so that was hinge, we are having what 225 by what 225 and bar is what 4y what 16, okay. Why this one that is fixed, the same size, span length, the same, everything the same and the same loading, but we are having what 300 at what 225, and then the size of bar of the bar is what 4y25, which is far more expensive for the client to do what afford. That's because you made a simple mistake of what non hinging and what applying as what as fixed, okay, that's fine. Again on this other side too, now let's now also make here to be what stable, okay, and then come again here, right click now and then do this again right now, and then come again now and then check out right now why it is failing again. You can see that it's based on what the same reason, all right. Then come now, okay it now, and try to do what increase again the size again to what, let's try 250 first and see 250. And now you can try this on your own, okay? It will take time. Highest thing 30 minutes and another. So try it on your own. Consider it is failing here. Then come and try what? And try 300. Let's see 300 and see 300 and see. Consider it is passing. Consider it is passing. Now you consider it passing, but still what? Still 4y 25. Okay, we can treat this later and all that. Okay, that's fine. So okay, then okay now, and then now okay again. So you can see that basically you can see the size of the column that is doing what? That is trying to carry the weight of this beam, just, and that is what? That's a fixed end. Okay, so all these things is happening. The reason why the size of column is bigger in section and you're having bigger reinforcement is simply because you didn't apply what? Hinge. You applied what? A fixed end. Simply because you applied a fixed end, that's why you are seeing all these things happening. You are wasting the client's money. Okay, so you can now see that when it is a hinge end, as you can see here, this is the first one here is hinge. All right, this circle here is hinge, and the last one here is what? Fixed. Okay, so when it is a hinge end, you can see that what we got, all right, when it's a hinge end here, hinge end, we get it to be what? Column to be what? 4y what? 4y 16 for the column, and the column size is what? The same as it is here. Then for the beam, we get to be what? We get to be what? 2y 16 and 4y 20 at the bottom, and then the column size to here the same thing. Okay, 4y 16 bar, and the size is 225. Now for the fixed, when it is fixed, now when this is fixed, you can see now that the column size increased. That because there was a failure, so we now have to do what? Make it to be what? And stable. Because when you're designing, you focus first on stability. Then while you're focusing on stability, also focus on the cost of the construction of that building, because a good design must not be too expensive, even if you're focusing on what? On the stability. So while you focus on the stability, also focus on the cost of that structure. Okay, because if you design a perfect building, that's fine, but if the cost is too much for the client to like afford, it will be what? It will be the client will just do what? Abandon the what? Project, and which is not nice, and the main purpose of what you did design for didn't come to pass. So that's not nice. So while you focus on the stability of the structure, also put your eyes on the cost of the structure. Is very, very important, and you'll be able to reduce all these costs. You can see how we have now. If we now check the cost of these two beams, here is what? Hinge, and here is what? Here is fixed. First, let's start with the column sizes. You can see that the column size that was able to carry this beam with the load and the and everything, having a hinge end, is what? 225 by 225 by the bar of what? 4y16. Okay, whereas this other side here for the column, you're having what? 225 by what? 300. Okay, and a bar of what? 450. Can you see that? Which is what? Far more expensive compared to constructing the one that has what? That has a hinge end. Okay, that's fine. Then for the beam now, for the beam, you can see that the beam has the same depth. Yes, that's because of the span. 7.5 is too big. All right, is at least is quite longer than, yeah, is quite long. Now the same span here and the same depth, that's fine. Now, but for the reinforcement, for the one of the hinge, you can see that we got what? 2y16 top and 4y16 bottom, and 4y20 bottom. Okay, now but for the one that is what? Hinge, sorry, fixed. Okay, fixed, which is here, fixed end, we got 3y16 top and what? And 6y20 bottom, of which this fixed end, this one that is carrying fixed end, is more expensive for the client to like construct compared to this. Now if you look at the two are both stable, but just that because of the end conditions, this one has bigger section in column and bigger size of what? Reinforcement for the columns, and for the beam, it also had higher number of what? Reinforcement for the at the top by what? By +1, and at the bottom it has additional number of what? Reinforcement by +2. okay, at the bottom. So you can see that the one that is carrying hinge end is more cheaper compared to the one that is carrying what fixed end, and the both are what stable. So if let me assume that Mr. John, right, engineer John is the person that did this design for a client, and for the same client again, Mr. Let me say Peter, all right, engineer Peter did the same design, the same model, everything, the same load and everything for what, for the same client. Okay, now you can see that first the client will just look at the stability of the both structure. They are both stable. Okay, now he will now look at the what for the costs. Okay, now checking the cost, now you can see that the cost of Mr. John's design is more cheaper compared to what Mr. Peter's design. Okay, so the client has no option than to choose what Mr. John as the structural engineer and as the engineer at site, and he will pick his model because one, it is cheaper. Now the simple reason why Mr. John, all right, is more cheaper compared to engineer Peter's own is just that engineer John have more experience on hinging, okay, on end conditions of beam, all right, knowing that whichever end condition you apply, as long as you apply the end condition well, they are both stable. Okay, that is number one thing you should know. Either you apply fixed or pin, as long as you apply the hinging well, it is stable, it is okay. Okay, that's fine. Now let me now explain it now. For example, let me just use now for example. I want to just do an example, like a physical example, a real life example. But let's just continue first. If it comes to my mind, I'll just tell you guys again. So right now we have not checked for this one span beam and all that. Let's now go and do what, check out for this continuous beam. Okay, now for this one, you can see that for the other continuous beam, now we applied we applied for the first model, there was a hinge here, all right, and also at the end here there is a hinge here for the first model, for this first model here. Now on the other model, now on this other one here, we didn't here is fixed. Can you see that? And here also is fixed. Can you see that? Compared to this first model here, that we applied what hinge and what hinge. Okay, hinge end. Okay, now let's now go and see the impact it will have on the what, on the columns. Okay, now if I now go to the status here, you can see that yes, they are all green, they are all okay. I can see that they are all okay. Can you see that? They are all okay. Now let's now go and look at the reinforcement each of the columns is what carrying. Let's start with this one, that is pin here. As you can see that this first one here is pin. Okay, let's start with this one now, that is what, pin end or what, hinge end. Okay, hinge end. So with this now, let's now look at the column 5 here. Let's see what it carries. Let's see that now. It's coming up. Let's see. You can see that here is carrying what, 4y16. Can you see that? 4y16, correct. Then okay it now, and then cancel first. Then let's now go and look at the other one now on this other side, which is the fixed end, the other model that is fixed. Check here now, check here, and then let's see what it will carry. You can see that it is carrying what, let's see. You can see that 4y20 against 4y16. Can you see that? That's fine. So okay again. So you can see that the hinge is for a continuous beam. When you hinge a continuous beam at the end of the beam of a continuous beam, as I have hinged like this, all right, it is more cheaper compared to when you don't hinge it, when you just model your plan like that on the structure, or like on this software without applying hinge end and all that. Okay, so let's go back now to where it is. Then again, let's now look again for this other final one here, this other last column here for this first model here. So check out this now, right click now, design check here. Then you can see also that let's see, here is given what, 4y16. That's for the hinge end. Okay, 4y16 for the hinge model. Okay, again right now just cancel here. Let's now look at for this other one that is what, fixed. Okay, fixed here. Let's see that now. See that now. Check here out. Let's see. Come here. You can see that here is what, 4y20. Can you see that? Which is more expensive compared to what, 4y16 that the hinge end gave us. Can you see? That's fine. Okay, so again now cancel. Okay, so let's now look at the BM diagram now. Let's see the BM diagram first for what, when it's what, hinge. Okay, hinge end. So right now let's see now. BM diagram now. Let's just say okay first after I can do that. Okay, now the BM diagram now is here. Okay, now you can see that the BM diagram now is what? Is at what? 0. Can you see that? Is at 0. Okay, at this end here is fixed, which is the middle. So for a continuous beam, you must not hinge the support that is what? Internal. Only hinge the ending. Okay, so because of that, you can see that we are having what? This. Yes, it's fine because this is what? This is for a mid span. But for the ending here, we applied what? Hinge. You can see that the what moment here is what? Hitting at what? 0 line. Okay, now let's now go and see what? Let's now go and see for the other one, for the other hinge end. This is the hinge model. Sorry, this is the fixed model. Okay, the fixed model. So come here and then do that now. Let's now see the fixed model. Let's just see that now. The BM diagram. You can now see, you can see that now that there is a top moment, all right, of what? 32.6, right, which is induced. It is this force here, right, this moment that is causing this column to have what? Y20, right? So why not remove the moment by applying what? Hinge end, okay, of which the beam will be stable. Everything will be stable. Now let's now look at the both what? Reinforcement for the beam. Since we have checked for the columns, okay, and we can see that for the hinge end we have what? 4y what? 4y16 for the hinge. Now for the fixed end we have what? 4y20. So which one is then cheaper? I believe the answer will be what? Hinge is cheaper based on the column what? Bars. Let's now look at for the beams, okay? Correct. Now for the beams now, let's now see. Now let's now check. Let's start from the for the one that is what? Hinge, okay? Hinge end. So from here now, we now check out for what? This here. Here, correct. Just okay here. So you can see that basically they will have the same reinforcement for the beams. You can now see that we have what here? We have here 2y16, 3y. Let me just take to 16 instead of 12. Yeah. Okay, yeah. 2y16 here, 2y16 here, correct. 4y25 at the support. That's because of what? This moment here at the support. Can you see that moment here? So it now requires higher number of bars to push back this reaction back to its what? 0 line. All right, that's why you're having that. Okay, then you can see that we are having what here? Y25, y25. Okay, I won't change anything now. I'll then go and do what? Okay, so just watch now. We have what? 2y16, 2y16, 25, 25, 22, and here is what? 4. Okay, let's now go and look at for, let's just say okay, and then go and check the one that is what? Fixed. Okay, fixed end on. Come here now, check this again right now. Okay, that's fine, and then okay here. Okay, now on this now you can see that we have the same thing. Okay, 2y16, 2y16, correct. 425, correct. 225, 25. Okay, that's fine. You can see now that for the beam, for a continuous beam, no much effect. Okay, all right, but you have seen that the main effect happens on the support, which is the column, because the moments around this region here where the moment change here. Let me just show you now. You can see that now this place here now has induced moments. Okay, so it transferred into the column, the support, all right, into the column. That's why we are having this column here on this support here to be what? To be 4y20, whereas the other one that was hinge is giving us what? 4y what? 16. So you can see that this 4y20, that's because it has what? Moment of what? 32 point something. Okay, going into the supports and all that. So now you have seen how we have now done what? If you look at what I have just done now, all right, you can see that we have everything the same span. We have the same span 7.5 on the both models. Okay, the same column size as of before, but after our design, the column size for the fixed end changed. That's because a moment of 17 kilonewton meter was entering into the column. Yes, that's what fixed end does. Fixed end used to do what? Induce moments at the support top moment, so which will either affect the beam or it will affect the support. It must affect one. Now in this case it affected the column, and the column get bigger. Okay, whereas for the other one that is hinge, where we apply what hinge end, you can see that everything looks okay. Okay, the column size is okay, the bar size is okay, everything looks okay. Okay, no, so now you can ask, and all the models here, all of them are stable. Okay, but now the difference now is on the section sizes and the costs of the construction. Okay, so when you are doing your next design, consider applying hinge end basically on your structure. We have done a lot of videos about hinge end. There is no design you will see on our channel that we will not apply hinge end. That's because over the years we have seen that when you apply hinge end on your structure, it can cut up to, let me say, 15% of the costs for the whole construction. It can save you that. It can save the client 15 to 20% of the cost. For example, now you can see that this one here, this column here that is fixed, is 300 by 225, whereas for the one that is pin, hinge or pin hinge is 225, and having 4y16. Why here was having 4y25, which is more expensive, almost times 4 of the cost of this column, almost times 4. Yeah, correct, because y25 is more expensive compared to y16. Y25 is almost times 2 of the cost of y16. Correct. Don't forget that after y16 we have other sizes, 18, 20, 25. So it's like times 2 of the cost of y16. That's what you're given to for. So you can see how we have now explained this. Now, from the beginning, I said that it not be interesting based on you won't be seeing visual buildings massive, but if you stay to the end, you'll be able to see how this thing will affect. And I believe by now you have now learned the reason why you must hinge and all that. Okay, so apply hinge. If you have not known how to hinge very well, you can enroll for Ekidel mentorship class only on hinging. Okay, if you have known all the rest on our mentorship, you can just pay for hinging and we will teach you all about hinging principle, how to apply it. Okay, so if you want that, you can go to our bio. Either on our bio you will see our WhatsApp platform number, or check on this video description WhatsApp. You will see WhatsApp number. Chat us up, and then we will send you or create a link for just the hinging area. This hinging is very, very important. As you can see, we used to shout it on almost all our videos and all that. So you can learn either from the video we have posted, but if that is not enough, then you can now pay separately for just hinging, which will be cheaper compared to the whole mentorship. Okay, because I believe by now you must have known how to design one story and all that, so you can pay for only hinging, and then we'll teach you more hinging. But for the people that cannot afford it, you can watch our videos here that we have, check our channels, and then check out the video that we have done for hinging. Okay, that's fine. So thank you so much, and God bless. Now basically this is the month of April, and we are about ending our we gave out 50% discount on Ekidel mentorship. So it will end this April, and this is less than 8 days to go for this month. So our advice, you do you enroll now that we are still giving out discount. Okay, so right now go and enroll for Ekidel mentorship now that we are still giving out discount. Okay, after this month of April, it will be back to its original price. So thank you so much, and God bless you. We love you, and then bye for now. I believe you have learned a very good thing. So if you are a new subscriber, and please consider subscribing to our channel, and if you are an old subscriber, consider joining Ekidel Premium membership here on YouTube. You will enjoy the videos that we have there, as most of our videos are only for members, and those videos are well explained. Okay, thank you so much, and God bless you. We love you, and then bye for now. Then bye. We love you. Then okay, that's fine. If you want to learn structural design, then Ekidel is the best for you. By clicking the link, you are already one step ahead. Don't miss this offer. Enroll now.